back. A little more Math 101 today. I'm talking about LCM, and now we're going to talk about the LCM of three numbers. So let's try our buddies from a previous lecture. We're going to calculate the LCM of 12, 18, and 30 today. And again, we're going to do this by four different methods, although we have to shake up the other two methods just a little bit for LCM. LCM is going to be a little bit harder than GCD. All right, so let's get to it. First method is list multiples. So in this case, we might have to go pretty far out. Let's do 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144, keep going, 156, 168, and 180. And I could keep going, and I'm going to stop there. Let's see, 18. I have a little harder time making my 18 times table, but let's give it a shot. 18, 36, 54, 72, 90, 108, 126. Yes, is that right? I had, let me see, I'm going to add 20 and it's to take away 2, so 128 minus 2 is 126, yes. 144, 162, 180, 196, okay, oh, no, 196, 198. I could keep going, and we'll stop at this point. 30, let's look at the multiples of 30. This one's easy, 30, 60, 90, 120, 150, 180. Okay, so now I'm going to look for common multiples in each of these lists. When I mean common to all three lists. Let's see, 12 is not in the second list, 24 is not, 36 is in two of them, but not in the third, 48, no, 60, no, 72, two, but not the third, 84, no, 96, no, 108 is in two, but not the third, 120, no, 132, no, 144, two, but not three, 156, no, 168, no, 180, jackpot. So 180 is in all of these lists. Right, so it's the first number in all of the lists, so the LCM of 12, 18, and 30 is 180. If you are in a situation where you haven't yet found a common number, the only recourse if you're using this method is to continue expanding your list. So keep going. You might be able to use a calculator to accelerate the development of these lists. There are ways to get calculators to produce the series of numbers just by pressing the equal sign over and over again. But anyway, however you choose to do it, you may have to extend the lists until you find some number that's in common. And you may have to go all the way up to this big number, 12 times 18 times 30. We're lucky because we didn't have to go all the way up to that big number. But if you're going to use this method, you may end up encountering some very, very large numbers. So this method is useful to help understand the meaning of LCM, but it's not a great way to calculate it. Okay, so now we're going to look at method 2. Factorizations and factor trees. So factorizations, we've done the factorization for 12 and the factorization for 18 numerous times. I'll leave that up to you if you're still rusty at it. 30, let me see, 32 times 15, 15 is 3 times 5, and these are all prime. So the prime factorization of 30 is 2 to the power 1 times 3 to the power 1 times 5 to the power 1. Okay, so we now have 3 factorizations. I'm going to open that up on the next page here. Factorization for 12 is 2 to the power 2 times 3 to the power 1. Factorization for 18 is 2 to the power 1 times 3 to the power 2. Factorization for 30 is 2 to the power 1 times 3 to the power 1 times 5 to the power 1. We're going to complete these columns, and there. Now the LCM is the largest number in each column. So largest in the first column is 2 to the power 2. Largest in the second column is 3 to the power 2. Largest in the third column is 5 to the power 1. That is 4 times 9 times 5. And that is 36 times 5, which is 180. So again, we have LCM of those 3 numbers is 180, but we got it fairly rapidly because we were able to find the factorizations of our 3 numbers. Okay, so that is LCM of second method for LCM of 3 numbers, the factorization method. That works when you have factorizations available. You don't always have factorizations available, so we're going to use method 3, Euclidean algorithm. And subtraction, as usual, is going to come first. So let's take a look at what we got. LCM of 12, 18, and 30. Now, there is a formula for this that is unfortunately rather complicated, and I think I'm just not going to go there. So there's a nice formula. If you look back at the LCM for 2 numbers, there's a very nice formula that makes sense. It's easy for us to explain. But the formula for method 3 is rather more complicated. So we're not going to, I'm sorry, the formula for 3, the LCM of 3 numbers is rather more complicated. So I'm just going to avoid that. What I'm going to do is depart from our usual framework here, and I'm just going to write down the way I prefer to calculate the LCM of 3 numbers. That is to find the LCM of the first 2, and then use that result and find the LCM of that result with the third number. Right, so this is a rule that mathematicians have figured out is always correct. It always works. You can sit down and contemplate it yourself, but you can just trust me as well. That works. So what I'm going to have to do is do 2 different LCM calculations. And so the first one we've already done. You can review that if you like, but the quick bare bones summary is that I take 12 times 18, I divide by the GCD of 12 and 18, which I figured out by the subtraction method, and that was 216 divided by 6 is 36. So that is an intermediate result. So we're going to continue our original calculation, substituting our intermediate results in. And now again I have the LCM of two numbers that I need to calculate. I can do this in a variety of different ways, but since we're especially talking about the Euclidean algorithm, let's use Euclidean algorithm subtraction version. So over here on the side I'm going to do GCD of 36 and 30. That is the GCD of 6 and 30. I subtracted the smaller from the larger. That's the GCD of 6 and 24, GCD of 6 and 18, GCD of 6 and 12, GCD of 6 and 6, and that would be 6. So that tells us that the LCM of 36 and 30 is 36 times 30 divided by GCD of 36 and 30. That is 36 times 30, divided by 6. And final result is 180. Okay, so that is how I suggest that you calculate the LCM of three numbers using the Euclidean algorithm, is to break it into two number steps. So I figure out the LCM of the first two numbers, then I plug that result into my formula, find the LCM of that result, and the third number, that gives me the correct final answer. And finally, fourth version is really no different from the third version method for, let's say I'm going to use the Euclidean algorithm with division. So Euclidean algorithm with division, we have the LCM of 12, 18, and 30. My way of breaking it up is find the LCM of the first two numbers, and then use the result there. So now I'm going to do a little aside. LCM of 12 and 18 is 12 times 18 divided by GCD, 12 and 18. And here the GCD of 12 and 18 is equal to the GCD of 12 and 6, which is equal to GCD of 0 and 6. So that's just doing divisions, two divisions. I'm not writing all the details at this point because I've already done it. You should know all this already. Final result here was 6, and so this LCM, this LCM is 12 times 18 is 216 divided by 6. I got 36. Okay, so I'm going to continue with the first outer calculation here. I just substitute 36 for that first LCM, the second LCM. Substitute 36. And now, this was not 18, it was 30. Okay, so I'll clear this up. Sorry. There. Sorry for the confusion. We had LCM 12 and 18 is 36. That is the only result that I used to get down this arrow. So now I have a question I'm facing is, what is the LCM of 36 and 30? Again, we can use division. So this will be 36 times 30 divided by the GCD, 36 and 30. To find that, I use the Euclidean algorithm with division. So 36 divided by 30 goes in one time with a remainder of 6. $30 divided by 6 goes in 5 times with a remainder of 0. 6. 36 times 30 divided by 6. And calculator will tell you that is 180. And so that is the fourth method. Very similar to the third method, pretty much the same as the third method. But I'm just doing the GCD calculations using division version of the Euclidean algorithm instead of the subtraction version. So that is my fourth method for the LCM of three numbers. So now we should be able to calculate the LCM of any three numbers. So let's do another problem. Here's a word problem. I have I go shopping. I'm doing a fundraiser, and I'm going to sell cheeseburgers at this fundraiser. And so I want to efficiently purchase what I need to make cheeseburgers. So what's in a cheeseburger? So I'm going to have the burger patties. And they come in sets of 12. I get 12 patties in a box. I have buns, and there's 8 in a pack. So right away we see we've got a kind of a problem. If I just bought one pack of buns and one pack of burger patties, I'd have 4 patties left over and no buns, and so that's not very efficient. So what I want to do is make enough burgers so that I completely use up all my buns, all my patties, and since I'm making cheeseburgers, I want to use up all my cheese slices too. And of course, they come in a different pack size too. All right, so how many burgers I'm going to make is the question. The number of burgers has to be a perfect multiple of 12 because I want to use up all my patties. So I want a multiple of 12. I also want a multiple of 8, and I also want it to be a multiple of 16. So that is, I want a common multiple. I want the number of burgers to satisfy these 3 conditions simultaneously. So I want a common multiple of those. And since I don't want to overdo it, I want to see what the smallest number is. And so I am going to want the least common multiple of those 3 numbers. Okay, so that's the problem. Now we need a strategy. We need to decide which method we're going to use to calculate the LCM. What I'm going to suggest is that we try it with the factoring method. We are very familiar with the factorization for 12 and 8. I'm just going to blast this one out right away. I know it. 16 is 4 times 4 is 2 times 2 times 2 times 2. So I should circle primes. Okay, so let's calculate LCM as 12 is 2 to the power 2 times 3 to the power 1. 8 is 2 to the power 3 times 3 to the power 0. 16 is 2 to the power 4 times 3 to the power 0. LCM is 2 to the power 4, that's the maximum in the first column, times 3 to the power 1 in the second column. That is 16 times 3, and that is 48. So what I should be aiming for is to make 48 burgers. Let's see how many of each pack I need. 48 burgers. That is 48 divided by 12 equals 4 packs of burgers. These are cheeseburgers, right? Get that word cheese in there. Okay, these are 4 packs of patties. I'm going to have 48 divided by 8, which is 6 packs of buns. And 48 divided by 16 is 3 packs of cheese slices. Okay, so that is how math can make our lives better. I suggest that you try this question using other methods for LCM. Okay, one last application. I mentioned the Julian calendar system. So there's the whole Julian cycle, and the Julian calendar system is based on noting that there are 3 very important cycles in historical literature. There's a 28-year cycle, and that's the cycle of the Julian calendar. The Gregorian calendar has a 400-year cycle, but the Julian calendar has a much shorter 28-year cycle. So that's when days of the week fall on the same date, and and also the leap year pattern is the same from one year to another year 28 years later. So that is the cycle of the Julian calendar system. Then there's the cycle of indiction, and that is the taxation cycle established in the Roman Empire, and it lasted for quite a long time. So that is historically very important, 15-year cycle, and also a 19-year cycle. And so the Julian calendar cycle altogether is the least common multiple of those 3 numbers. And so I would like you, as another exercise, to figure out what that is, how many years before the Julian calendar completely cycles around again. So using Chinese remainder theorem, which we've already discussed, we're not going to go into all that detail again, but using the Chinese remainder theorem, coupled with knowledge about where you are within each of these 3, can uniquely establish a date within this entire cycle, and it's several thousand years long. So I'd like you to please figure out how long that cycle is in years. So that's my other question I'm going to leave you with. And if you're having trouble, I can maybe do up another lecture, but I'm hoping that everyone will be able to do both of these problems fairly easily on their own. Okay, so that's it for LCM of 3 numbers, and I think that pretty much ends our GCD and LCM section. So we're good to go for our next upcoming quiz. The quiz will be asynchronous, so I will just ask you to go off and do it on your own and submit it when you feel like. You'll have a limited amount of time to do it, but you decide when you want to start doing it, and I'll probably just make it multiple choice so the computer will grade it on the spot for you. All right, so just be a couple of multiple choice questions that will open on next Thursday. I believe that would be, I've lost track of the dates. What is the date today? That'll be 26th, I think, of March. On Thursday, I'll open the quiz, and it will cover material that we've done up to this point. So that'll be GCD and LCM mainly, and then We will continue with some new material shortly, but it won't be on Thursday's quiz. It will be on the quiz for our April 9th, I believe is the next day. All right, so anyway, final bottom line is quiz opens Thursday for 1 week. Start it when you want in that week. I will give you a limited time, either half an hour or 1 hour to complete. I have decided yet. Once you start it. And the contents of that quiz will be GCD and LCM. Okay, that's it for now. I will post some more lectures on more material, new material in number theory, starting probably tomorrow, but it won't be on the upcoming quiz. All right, talk to you all later. Stay safe. Bye.